All right, I'm just going to show you how to do the PreQuiz 20.2. Okay, this first thing here is just I want to do a cross product, right? So it's this cross this. It's like this is IL and then this one's B. This one's I times L and that one's B. The X here doesn't mean anything except do this thing with your fingers. Okay, so for this one, it's going to be IL is this way, right? And B is that way, right? IL that way, B this way. That's why there's a dot there. That dot means out of the page, right? This one is, IL is into the page, and B is this way, right? So IL is this way. Make sure you're using your right hand, right? B is this way. Up the page is the force, right? This one is down the page. So index finger that way. B is out of the page. That's what the dot means, right? And that's why the arrow is pointing that way to the left on that page, right? And then this one is out of the page, cross down, right? Out of the page, cross down is to the right. There we go, right? Now these ones here use the wrap your finger around the wire rule. So your thumb is the direction of the current, and you're going to wrap your finger, and that's the direction of the magnetic field, right? So here we've got a current to the right, and the question is, what's the magnetic field below the wire, right? Well, what I'm going to do is I'm going to wrap my fingers around, and I'm pretty sure on that side there, right, on the front side, on the bottom side, my fingers are going into the page, right, and that's why there's an X, okay? This one is going up the page, right? That's the current, and I'm pretty sure where that B is, my fingers are coming out of the page, right? I wrap my fingers around, my thumb is in the direction of the current, right? Here the question is, which way does the current have to flow so that it's out of the page there and into the page here? Well, I think it's to the right. Yeah, it's coming out of the page on that side, into the page on this side, to the right. And then this guy here, the current's going down. So on this side here, hey, there he is. On this side here, it's coming out of the page, and then there it's going into the page. Yeah?
Can I borrow this?
Yeah, go for it. All right, so that's those ones. That's that right-hand rule. This one is the rule about the loops. So we want to figure out which way the north pole is. The way this works is if you wrap your fingers the way the current goes, your thumb is the north pole. Okay, so this one's easy. It's going anti-clockwise, and my thumb is out of the page. And of course, this is the reverse, right? It's going clockwise, so it's in. Now, it's interesting to note that if that was a right-hand thread, and I turned it that way, it would go away from me. If I turn it this way, it would come toward me, right? This is how I don't mess up bolts on the other side of the engine. I get those right because I know which way to turn them to make them go away from me or toward me, right? So if it's on the other side of the engine, it's got to come toward me to tighten it, away from me to, right? So you actually, right, to make it go away, you're actually going to go that way, right? Okay, so here's this coil. This is supposed to be a coil of wire, and the north pole, if the current is coming around the front of that, like that, okay? Well, then the north pole is the top side, right? And then here, if that's the north pole, the current's got to go up the front, up the front of that thing. That's why there's a little up there, right? Up the front, that's the north pole. These ones are just straight out this thing. Okay, we're going to do that thing with it, right? So current is going to go that way. I'm going to cheat here and rotate it, right? Magnetic field is into the page. My thumb is up the page. That's what that little arrow is there, right? This one is current is that way. Magnetic field is that way. My thumb is into the page. That's the second one. Now it's getting all savvy, right? The force has to be this way. So my thumb's got to be that way for that one, right? Index finger's got to be this way. My middle finger, the magnetic field is into the page. That's what the X is, okay? And then this guy here is, let's see, force has got to be that way, right? Force is to the right, okay? Magnetic field is out of the page, so the current's got to flow up the page. And that's why it says up the page right there, okay? Now these are particles, and the only tricky thing about particles, we still use this rule, but with particles, negative particles do opposite what the other ones do, right? Okay, so for this guy, the velocity is there, that way. Magnetic field is out of the page, right? And so the force is to the right on the page. And since it's a positive particle, it really is to the right. This guy here, the velocity is that way, right? The velocity is that way. The magnetic field is out of the page. The force is up the page, but it's a negative charge, so it's negative up the page, right? Remember the formula for it is F equals Q VB sine theta, right? And that's in the right-hand direction. Yeah, okay. And so since charge is negative, it's negative in the direction of the right hand. Or some kids, you could use your left hand, but that's a slippery slope, okay? Now this one is one of those map problems where you're looking down on a map into the page is interpreted as down, so X is actually down and dot is actually up. Yeah? Okay, and so let's see, a proton is moving, it's got a vertically downward force, so the force is into the page. It's got a northerly magnetic field, right? I'm going to move the paper instead of my hand, okay? So it's a downward force, a northerly magnetic field, yeah? So therefore it's got to go, I'm heading toward the west on that little compass rose there, yeah? So I'm going to go west, to the left on the page, right? An electron moving east, well, let's move east. I'm moving east, experiences a force to the north. Well, how convenient, right? Okay, my finger's moving east, it's to the north. The magnetic field is, well, it's into the page, right? But it's an electron. Electrons are negatively charged, so it's negative into the page. I hope that helps. That's why it's a dot, right? Negative into the page is out of the page, right? Okay.